Alright, so in this video, we're going to be rationalizing the denominator of complex numbers. So like this says here in this section, it says in previous math classes, you should have rationalized the denominator. Um, so in this case, what we don't want are i's in our denominator. And so we can kind of do the same thing with complex numbers by multiplying by either I or the conjugate. And so what we multiply by depends on what we have on our denominator. So in examples 1 and 3, which we're going to do, we can see we only have one term here in our denominator. And that's going to be this 5i here or this negative 6i here in our second example. Whereas in our bottom two, we have two terms, with it being negative 1 plus 3i or 9 plus 8i. So let's go ahead and do our one-term example first. So 3 divided by 5i, in the case where we only have one term in our denominator with our number times I, or just maybe even just I itself, we just have to multiply both our numerator and our denominator by I. So 3 times I, well, that will give me 3i. And then 5 times I, or 5i times I, will give me 5i squared. And then, so using our powers of I know that 3i is going to be the same, but I squared is equal to negative 1. So essentially, 5i squared is the same thing as 5 times negative 1. And so 5 times negative 1 will give me negative 5. So simplified here, I will have 3i divided by negative 5. So if I was to rationalize the first one, that would be my answer. Again, I'm going to go ahead and now look at the next example, again, where I have one term on my denominator. So again, I will just multiply by I on both my numerator and my denominator. So I distribute the I for the first one. That will give me negative 3i plus 10i squared divided by negative 6i squared. So again, when I go ahead and I simplify this, negative 3i is going to stay the same, but then that's going to be plus 10 times negative 1. And then on my denominator, that will be negative 6 times negative 1. So I'm going to go ahead and simplify this down here. Negative 10, or not negative 10, negative 1 times 10 will give me negative 10, and I'm going to go ahead and move that to the front to write this in standard complex number form. So negative 10 minus 3i divided by negative 6 times negative 1, which will then give me a positive 6. So again, if I was to rationalize number 3, negative 10 minus 3i divided by 6 would be my solution. Now, also, one thing that we should do is always go ahead and check if we can simplify our answers further. In numbers 1 and 3, I don't have a GCF or a number I can divide all three of my numbers, or in the first case, both of my numbers by. So we're just going to go ahead and leave it as is. So then, we are now going to look at number 5 and 7, where in these ones, we have two terms in our denominator. So again, this is where we change things up here. Instead of multiplying by just I, we're going to go ahead and multiply by our conjugate in the numerator and our denominator. So our conjugate of negative 1 plus 3i would just be negative 1 minus 3i. We're just going ahead and we're flipping this sign. We're changing that to its opposite sign right there. So negative 1 minus 3i. And then I will go ahead and now distribute this out. So that will be negative 8i minus 24i squared divided by, now when I multiply this out here, I'll get 1 plus 3i minus 3i minus 9i squared. And so if we are observant here, we can notice that negative 1 plus 3i and negative 1 minus 3i will give us a difference of squares. And that, as we see when we go ahead and multiply out, would end up canceling out these two terms here, the plus 3i and the minus 3i. So in short, this is actually just going to be equal to negative 8i minus 24i squared divided by 1 minus 9i squared. And then again, just like our previous examples, I can go ahead and simplify this using my I powers. So negative 24i squared, that's going to be negative 24 times a negative 1, which will give me a positive 24 minus 8i divided by, I'll have negative 9 times negative 1, which will give me a positive 9. So positive 9 plus 1 will give me 10. And in this case, unlike the last two, I can go ahead and divide 24, 8, and 10 all by 2. So when I divide every single one of these numbers here by 2 and simplify this down, this is going to be actually equal to 12 minus 4i divided by 5. So I want to go ahead and get the most simplified answer possible. All right. And then again, looking at our last example here, number 7, this one is also going to be a question where I'm going to multiply by the conjugate because I have two terms on my denominator. So this time, my conjugate of 9 plus 8i is going to be 9 minus 8i. So multiply my numerator and my denominator by each of those. And then again, I'm going to go ahead and multiply everything out. So negative 5 times 9 will give me a negative 45. Negative 5 times negative 8i will give me a positive 40i. Negative 9i times 9 will give me a negative 81i. And then negative 9i times negative 8i will give me a positive 72i squared. So yes, that is a lot to write out. If you prefer to multiply these out by using the box method, I would go ahead and recommend doing so for those. And then on my denominator, again, 9 times 9 will give me 81. Then I'll get 9 times negative 8i, which will give me negative 72i. And then 8i times 9 will give me a positive 72i. And then 8i times negative 8i will give me a negative 64i squared. So I'm going to combine like terms and cancel things out here. So those two things, the plus 72i and minus 72i, will cancel each other out. But we'll get back to that in a second as I look at my numerator. So I'm just going to write this actually below because I have more space. I will have negative 45, and then 40i minus 81i will actually give me a negative 41i, and then plus 72i squared. And then I'll have 81. And again, like I said, these will cancel each other out, so that will be 0 minus 64i squared. Now I'm going to go ahead and simplify my I terms, or my I powers. So that will be negative 45 minus 41i, and then 72 times I squared will give me negative 72. And then on my denominator, 81, and I'll have 64 times I squared, which will be the same thing as negative 64 times negative 1, which will be plus 64. So again, I'm going to combine like terms once again. I'll do that below. Negative 45 minus 72 will give me a negative 117 minus 41i, and then 81 plus 64 will give me 145. So again, this was a lot of work for this one, but as long as we go ahead and again follow our same steps as we did on the previous one in the same concept of multiplying our numerator and denominator by the same thing, we should get to our answer quite fine.